Good day to you. This is Anna Galactic bringing you another science presentation on Wednesday, December 6th. This is 2023 from Chico, California. We're now going to cover the seventh cosmic unit, which I've led you to expect if you're tuning in for the first time to this channel. Be aware that you are not being redirected anywhere. Although I've produced over 350 lectures, more than half of solid quality, the others being basically warm-up for the past 2 years. But they're about 40 minutes long each. And what I'll be doing is summarizing all of that information today in one of the directed ends of this discovery vector, which is to give you the final secret of the universe so that you can visualize it and understand it. Partially, the effect of this, in terms of the good effect this will have for you, you'll become immunized to the bullshit of astrophysics, falsely so called, and really contemporary science, which has been completely compromised and is heading in the wrong direction for reasons which I've explained. And if you can't figure it out on your own, you can watch my previous lectures. Especially the one, I'll have a link in the description below for my devoted viewers, of whom you are now by definition one, since I have very few viewers. But if you're watching this, you can also click on another link, which is private, but you can link to it through this link that I'll have below, giving you the previous lecture, which was a pure rant. I just spilled the beans. It's totally psychoanalytic. It's actually kind of foul. You may not like parts of it, but if you hang in there, it's fucking hilarious. I laughed, and that can kill me with my asthma. Just laughing, I could just die laughing, literally. Which is probably not a bad way to go, but I don't really want to find out because none of us really wants to tempt death, you know what I mean? So, the seventh cosmic unit. Knowing this will give you the final key that unlocks the universe. I have about 24 extraordinarily significant secrets that science does not know yet, but most of that comes from the spherical geometry that I discovered in 2022. Where it led to was this, the seventh cosmic unit. This totally surprised me. A discovery vector is an astonishing thing, and it wears you out. It'll shorten your life, but scientists don't care, because the only thing we live for is for this. And if you can get to where I've gotten, you've reached the zenith, you've gone over the top, you're heading up. This is the goal. I've made it, but I still have my feet on the ground. And in science, we're under a vow to share. That is science. If you don't communicate what you know, you're not a real scientist. You have a private religion, basically. Whether it's true or not, no one will ever know or care. Well, that's not science. Science is collaborative and it's consensual. So you've consented to listen to this and you are in good shape now. Let me take a big drink here. So, according to my strategic approach to science, which is morphological, which is the correct approach, which is why I've been so freaking unbelievably successful, this is one of the keys, and I consider it to be, other than the quantum mechanical paradox solution, this is the second most important discovery of all that I made in terms of my ability to share this with the general public, but you are not any longer part of a general public, no matter how you look at it, but this is significant for you. Therefore, it's significant to me, and I intend to take this quite seriously if I ever get around to it. That's been 4 minutes of introduction. So, in the morphological approach, excuse me, I just realized I haven't taken my allergy pill yet, so I probably should. Give me just a moment. Just take a moment. It's right here. I have the pills. Here they are. You can see there. That's what I have to eat right now. Give me a mo. I'll even show it to you so you can see what I'm doing. I'm not leaving you out. This is not you being shunted off like a nasty dog while the big professor does his very important thing. No, see? That's what I'm going to put in my mouth right now. Look at those fingernails. That's from snuff. Okay. I did just shower, so the stuff under my fingernails, I'm too lazy to look. So, the first 6 cosmic units, we're just going to go through them quickly. You don't have to get out a notebook. I urge you to turn on your rational mind. Just shunt out the world. Just sequester yourself off to listen to this. I expect you to use your visualization system because it's going to be critical to what we're doing here, which is synthetic. This is the highest stage of science in the communication process, is the synthesis of understanding in your mind. So you're going to have to participate in this. I intend to make this pleasant, wonderful, to lead you into wisdom. That is my purpose. So let me take another drink. The first 6 cosmic units, which I have named, I didn't discover any of them. Although you could say the last one I did discover, and that's the one we're going to get to now, the 7th cosmic unit. What's a cosmic unit? It's a luminous object that statistically fills the universe. The first one of those everyone has known since the beginning of human time. It's the star. And that is the basic cosmic unit, because it's the only one that's particle-like. Now this, of course, is on macro scale. It's not like a microscopic particle, as the particle physicists call particles. But in cosmic space, we have an incredibly perfect analogy to that. At the micro scale is matched at macro scale. Basically, the proton of the universe is a star, because it's a gravitational object that's on fire, okay? It's 1,000,000 degrees or whatever they say, and it just radiates light like a son of a bitch. So that's the first cosmic unit, the basic one on which all but one are based. And the rest are extended objects out to the 6th cosmic unit. So to go through those quickly, I'll give you first the 6 names. Stelli, nebulae, cumuli, strati, Cirri, that's 5. And then comes the 6th one, which is not like the others because it's not an extended object. So we have one unextended object, the star. We have 5 cosmic units to follow, which are composed of stars. All 5 of them are. If I'm counting right, the next 4 are. The nebulae are the galaxies, which are made of stars, right? There are 2 types of galaxies. All galaxies are in cumuli, and these are spherical structures consisting of approximately 100 to 1,000 galaxies, and the cumuli are, and mark this well, they are the building block of the universe. You could say at the molecular scale. The atomic scale is a star. That is a particle. It would be a proton. So it's not a direct analogy, but this does have to do with centripetal force. The pulling in force that curves space, which Albert Einstein discovered that is exactly what is happening. Although he composed space-time, which has an error built into it, basically forced by linear algebra, and we're getting to that. Now hold those thoughts way in the back of your mind as we proceed through the 6 cosmic units so you fully understand the basic structure of the universe. This is not taught anywhere. Cambridge, Oxford, MIT, it doesn't matter. This is not taught because it leads to understanding. So I'm not going to go off on a rant again, but you're only going to get this from me. But I swear, and you shouldn't believe this, but I'm just telling you as a human, you can check the proofs that I've already published for every single thing I say. I'll let you know when what I say deviates from what is actually already known, because I have made some discoveries that go beyond what science proper knows. So, the basic cosmic unit is a star. But to jump to the other end, the 6th cosmic unit is called a quasar, and it is also, you could say, a solid object. That is, it's an unextended object. In our construction here, that's how we're defining a star. Because a galaxy is an extended object. And the reason it's called that is because it's made of stars, which are actually rather sparsely distributed. But when you have 100 billion of them, as Andromeda and our own spiral galaxy do have, then it forms an object, but it's called an extended object to distinguish it from an object like a star. So there are the first three. The star goes into the galaxy, and so a galaxy is made of stars. You know that? Well, then just keep going. What are the galaxies embedded in, if anything? All galaxies are in cumuli, and that's the basic building block because it's the last independent object. Fritz Zwicky discovered that the cumuli, which are spherical compositions of galaxies, have boundaries, and there's nothing outside of a cumula, or I still say cumuli, even though cumula technically would be plural. I have my own convention, don't worry about that. But you could say cumula or cumuli. So that is the third cosmic unit, which is significant because it's the building block of the universe, because in the next higher integration, at the fourth cosmic unit, you're now talking about a single object, and it's a web composed of two basic structures, which sounds like a contradiction, so hear this out because this is basic geometry, an incredible fact which I hope you appreciate, that this is utterly simple. So your visualization of the universe, if you want to just see it in your mind right now, picture a cosmic web. Can you do that? Let me be more specific. The cosmic web is composed of beads, and these are cumuli, they're spheres, and they're independent objects, but they collect into another sphere, which is the fourth cosmic unit, which used to be called the supercluster, and those exist, but they don't have the exact geometry that was first intuited. The natural intuition would be it's another independent unit, but these are not independent. They're cabled together with linear strands of cumuli. So everything's made of cumuli, and what do they make themselves into? These nexal points, which are like spherical, composed of cumuli, again on the order of hundreds, I believe is accurate. And the strands that come out in all directions spherically. And it's not just a giant mess, it's organized so that you can picture a sphere made of cumuli with, for instance, just begin simply with two strands coming out. They're not strictly speaking in opposite directions, although they could be. There's no reason for them to be that science has discovered. And so it appears random. We've not found an exact pattern, but they form polyhedra, and that is one amazing thing to be able to say, that at the highest structural level that we have observed so far, the visible universe is a giant interlocking polyhedron. And I have never heard another scientist say that. But you can see it, you can verify it in composite photographs of all sky surveys, which have been duly processed to bring out the actual geometry of the universe. Incredible. It's made of these vertices, and I hope you know geometry enough to know what a vertex is. It's a point on a polyhedron. And so it is a point, but of course the point is connected to edges. And these are the cables. Our own galaxy is on one of these cables. And the nearest supercluster, as they used to be called, which I have renamed the strati, the nearest strati to us is the Virgo cluster, which is an ambiguous name because it's not only the Virgo cluster, which is a cumula, but it's also part of a larger system called the Virgo supercluster. That has been renamed by the University of Hawaii, who managed to prove fairly well the geometry of our local supercluster, which is really saying something, so I hope you appreciate the name that they came up with. It is a Hawaiian name for our supercluster. It's called Laniakea. Laniakea. So we're in the Laniakea supercluster in the Virgo cluster, and then in the Milky Way galaxy at the star called Sol or the Sun. So that's where we are so far in the roadmap of our corner of the block in the universe. So at the Virgo supercluster, there are strands going out to the other nearby superclusters. And these interlock to form polyhedra. In the interior of the polyhedra are called voids, which are relatively blank areas, just open space. This is why we can see so far through space, is most of it is empty. Indeed, that is the case at the atomic level. The size of the protonic core in an electronic system is so remarkably small that you could look this up to get some really good metaphors for how to visualize just how much empty space is in an atom. I still can't comprehend it. I've tried many times. Every now and then you think, God, it's just... You end up saying, well, there's just way, way more empty space than I can really even imagine. It's like the protonic core is like a baseball. And then there's all these ping pong balls at a football like field away. And the electrons, this baseball in the middle at the 50-yard line, and the electrons are way up in the stadium, rotating around, whatever they do, which is highly debated, but don't worry about it, it is spherical. But we have the same thing in the universe itself, although obviously quite a bit different. I'm drawing a broad analogy so you can see the ultimate consistency of nature. It's a fundamental tenet of science. Its driving principle is that the universe is rational. That, if you can finally wrap your mind fully around that, will save your eternal soul. So this is nothing to snuff at. This is the science of heaven, as every single major religion on earth has declared, especially and particularly through Yeshua, who said, look up, look at heaven, focus your mind on heaven, get your mind off the earth. He's talking about what we're doing now. So, we have the web, and now let's go through the 6 cosmic units now that we have a visualization of the universe, based on the first 5 cosmic units, the 5th one of which is the web. Then the 4th one down are the nexal points of the web. The 3rd cosmic unit are the cumuli, the basic building block of the universe, composed of galaxies, composed of stars. Okay, now we're ready to go on. Given this complete system of the universe that goes out to the so far unbounded edge, although we're getting to that too, it can't be unbounded. It's not unbounded because it would be irrational if it were unbounded. And that, if you would, summarizes astrophysics today, that it still treats the universe as being unbounded. There has been an attempt at closure through the Big Bang, but that's a mistake, and I'll show you why. So, we have a web. It's just this giant web that goes all the way out to the edge. Even the James Webb Telescope, penetrating beyond the 10 billion light-year mark, has not been able to crack through this ultimate structure. So far, at the cutting edge of science right now, that is the structure of the universe, but there is something else, which has been partially discovered, but it's a mind blower, so get ready for this, because this is the 6th cosmic unit, and then we'll get to the 7th, which is most interesting of all. The 6th cosmic unit is called the quasar, and the quasar is equivalent to a star, but at the galactic level. It's a galactic star, because it's the birth of a galaxy. At least one. I'll throw that in. But what we've seen through our telescopes is we've progressively probed the unbelievable phenomenon of the quasar. In the approximately 50 years that we've been studying the quasar, actually a bit more like 60 years, we've progressively extended our knowledge of the quasar so that now we have cataloged, that is mapped, millions, over 1 million. And we're finding more, of course. But quasars have a very interesting light signature. They are the most luminous object in the universe, outshining not only a star, but they have the luminosity equivalent of a galaxy. So this is the birth of a galaxy. The astrophysicists don't say that because they have a model that forbids them from saying anything that might actually be true. So don't worry about what the astrophysicists say, just concentrate on what I'm saying. So far I haven't said anything that's not already known. I'm just presenting it in an organized way, which is part of the synthetic process, the highest stage of science and communication. So that's where we're at. The sixth cosmic unit, of course, is not any longer part of the sequence. I'll show you that it is, but this goes to the morphology of the universe, which morphology is not just structure, but it's superstructure, which goes to how the universe formed, which really science wants above all. Because if we can get how, that's the last step before why. That is, why is the universe constructed the way it is? You may have heard of the anthropological principle, which is a theory which has been developed and now strongly developed because science is lost in looking for anything, that it's being suggested by perfectly rational men with PhD degrees, that the universe was designed in order to produce the Earth. In other words, the universe is focused around humans. Its structure, this is explanatory, and I used to actually subscribe to this before the theory was actually developed. I had my own theory that the Earth was the only place that had intelligent life in the universe, which is now denied, and I would have to say that's probably more reasonable, although no one can really prove it one way or the other. You either think that there are other intelligences or there are not, and I could not see any reason to believe that there were other intelligences in the universe. Now that's incredibly naive and actually anti-religious even. But I knew that I had a divided mind on this, but so does science, so I was in a sense on the right track. Because what you're trying to do if you can't solve a paradox is you want to force yourself into the paradox, and then you have to go to the cloud and start using your imagination, which science does to push the envelope. And that's dangerous. You can actually lose your mind. But we have a built-in protective mechanism where we don't lose our mind, not normally, although Cantor did. In his study of infinities, he kind of went nuts and died in an insane asylum. Nobody's sure if that's what caused it. It could have been lead poisoning. Nobody knows. But it is an interesting lesson. Lesson in some form of strange scientific morality. Be sure you hold on to your mind when you go out into the cloud, or it could just dissipate and All right. So the sixth cosmic unit is the quasar, but it's not part of the structure as we've built it out logically so far. Star, galaxy, what's called the cluster of galaxies, and then the cluster of clusters, that's the fourth cosmic unit, which makes the Webb the fifth cosmic unit, which I call the Siri. And then the next cosmic unit, we return to a compact object, which is what the star is, and it's unique in the cosmic units as being a compact object, not an extended object, as all the others are, until you get to the quasar. And that is a galactic star. It's a galactic star. It's the exact equivalent of a star at the galactic level, the macroscale level of the galaxy. It is the birth of a galaxy. And the galaxies all come from quasars, as far as we can tell, as far as I can tell. So we're now faced with what is a quasar. In other words, where does it come from? Well, and this leads us into the seventh cosmic unit. We're now hard up on the edge of reaching what I discovered, the seventh cosmic unit, which is a mind blower. And that's what we're going to cover right now. But to get to it, you have to go through the first five, which we did, which are all composites of stars. That is, the star is the first, and the next four are extended objects consisting of stars. But the galaxies themselves come from quasars. So where do quasars come from? This is where we're introduced to the amazing phenomenon, and it should be called a phenomenon, the supermassive black hole, which is a remarkably stupid name. I've renamed these the Panther. And that's what I'm going to try to call these things from now on, so we don't have to keep saying supermassive black hole. Very misleading name. Mostly having to do with the fake mathematics used to devise the geometry of this supermassive black hole. When I rename it properly enough to Panther, think of that as the SMBH. That is a panther. Okay? So the relationship between the panther, which is a non-luminous object, to put it mildly, it is said to swallow light, but I'll show you that that's not precisely true. That would be actually a violation of special relativity. And in fact, the scientists are all fully aware that the supermassive black hole violates special relativity. Well, you may already know that at the quantum level, which is really the spherically opposite direction, this would be going in to get to the source of what is the atom, what generates the atom, that would be the proton, which bends space. And what's inside the proton, that's why we have so-called hadron colliders, which used to be called cyclotrons, and they still look like cyclotrons, but they have a much more glorious name since they're funded by the government. So now they're called hadron colliders. Hadron is a fake term. It's a subatomic particle physicist term for mathematical objects, which they call particles because they have no other word for the things that fly out from the proton-proton collision. They have about 36 of these subatomic particles named now. None of them are particles. But the proton is. The star is a particle at a higher macro scale, and at the highest macro scale, at least to the level that we're reaching here, that would be a panther. And the panther has two states. So this is the morphology of the panther. The sixth cosmic unit, which gets spooky fast, so pay attention. What is called a panther has two states, and the ones that we see that are associated with every galaxy, and you'll hear this repeated a memic amount of times, it is pure propaganda, but there is an element of truth to the statement that every galaxy has a panther. And just to remind you, that's a supermassive black hole. The correct definition that you want to hold in your mind of a panther in this state, so it has two states, but the one that we associate with all the galaxies in the universe, so this is a profound statement, is that it's a gravitational locus. That's a precision scientific term for a supermassive black hole, which I call a panther. But those are not quasars. What they are, and because well, obviously they're not, because a quasar is luminous. It is by far the most luminous object in the universe, and this would be a compact object of which there are only two, the star and the quasar. The quasar being one level up in cosmic structure in terms of its size, so it's an enormous luminous object. It's a galactic scale luminous object. It's not extended. So what happens with a quasar is it extends itself into a galaxy. And that is very difficult to say if it's been proved or not, but all the evidence that we found in our study of quasars shows that they do have, in the ones that we can see closest to us in a spherical range, we have found the beginnings of galactic structure around quasars. So there's also a timing issue involved. Because if quasars were really turning into galaxies, it looks like they're all turning into galaxies at the same time. In other words, we don't see something that looks like it has half a quasar or something half as luminous as a quasar with the beginning of a spiral galaxy. There are some, but not enough to confirm a discovery. And since it's antithetical to the Big Bang, no one wants to discover it, so no one will. It won't be researched. It's not being researched. But I have to research these things because they're facts. So to return to the panther, the state, one of the two states of the panther, which is not luminous, is the remnant of the panther. I call it the leaping panther. Think of it as being three states. There is a black quasar, which is what we're trying to define. So we're going to hypothesize a quasar before it becomes luminous. That is a supermassive object which has not been positively identified yet because it's not luminous. But you do have to answer the question, where do the quasars come from? This is a natural question, although difficult to answer. But it has to be probed. You have to guess, essentially. So this is the inductive phase of science, because we are now at the cutting edge, beyond which no one is gone except me. So you're now in the realm of discovery science, and you're now going to hear new information that affects astrophysics, cosmology, and all sciences and all humanity. So this is massively important, and pardon the pun. So we have three states. Before the quasar, we're going to call it the supermassive object. When it bursts into flame, I guess it's reasonable enough to say, when it bursts into light, when it becomes luminous, it's now in the second stage. It's not only a supermassive object, it's a supermassive luminous object. And then it forms a galaxy. Now, we would like to have a full spectrum of examples of, the interim states. We don't have that, so this is massively conjectural. But follow my hypothesis and see what you think. It will be up to you anyway, so you might as well get as much out of me as you can right now before you finally make your decision if this is true or not. That's what all scientists have to do, and it is up to you, as it has been up to me. So this is what I surmise, is that there is a supermassive object which becomes a quasar, and then, essentially, it's a controlled explosion. We see this in the bar spiral because it shoots out two jets in opposite directions to conserve momentum. It shoots out two jets, but it's rotating. And so these two jets, as they come out, it turns into a spiral. And that's called a bar spiral galaxy. The bar, which is very difficult to explain what is a bar spiral galaxy. I hope I've helped to explain what is a bar spiral galaxy. It will either degenerate into a pure spiral, or it may begin either due to some geometry that we don't fully understand yet, although we're getting there too. When it shoots out the two jets and is rotating, it may be that when the two jets shoot out, it's not as accentuated. In other words, it's more spiral than it is bar. The ones that we see, the so-called dragons, DRAGN, double radio-lobed active galactic nucleus, these are obviously quasars in process of expanding, attempting to become a galaxy, which is an extended object. So the stars will come from these jets. But it could do it in one of two ways in order to match Edwin Powell Hubble's tuning fork diagram of the two major kinds of galaxies. You would have to describe it here at the leaping panther, which is a quasar, becoming a galaxy. It could begin in a way that's subject to determining whether it will be a pure spiral or a bar spiral. So that's quite explanatory. What about the ellipticals? The elliptical galaxies, according to the current census of the universe of how many of each type of galaxy there are approximately 55% ellipticals. What are they? That would be, according to my theory, a leaping panther, that is a black supermassive object which becomes luminous and is now a leaping panther. It pops. Instead of shooting out two jets, it's more like a pop. And then out comes the material that forms the stars. And elliptical galaxies are now known to consist of what we consider to be generally older stars. They have more red stars, they're reddish objects, whereas spirals are far more exciting to us visually because they're blue-white. They're younger stars. And there's everything in between, and there are whole volumes of books written about the morphology of galaxies, all of which is well worth studying. I've studied it all. But here we're talking about the birth of a galaxy, which is not discussed anywhere because it goes against the Big Bang model. So this is off the main beaten path of science, which is funded, so it's not going to change rapidly. But as independent scientists, we're not funded. I'm not funded. So I am free to pursue real science. So that is essentially a better picture, I hope, of what is a quasar. Before it was luminous, it was a supermassive object. Now that I call a panther, but I haven't told you the third stage. Here's the third stage. After the non-luminous supermassive object becomes luminous and then either shoots out two jets or pops, it continues to form a galaxy, which then, that's what we see are galaxies, is the result of these, I call them explosions because there's really no better word. But it's a very controlled explosion. It's an electromagnetic explosion. So the morphology is largely governed by electrodynamics at supermassive scale. And this has been probed from many directions. It's essentially juxtaposed with our search for the grand unification theory, which has not been achieved yet, although I've achieved it, and we're getting to that as well, that the galaxies are not really described very well according to gravitational dynamics, and that's where we get dark matter from. A misformulation, but it is an accurate enough theory until you get the right answer for why do galaxies show a flat rotation. It should be that the gravitation is more concentrated according to the square law towards the center, but what we see is it's just a flat plate spin. And one way to solve that, if you're willing to hypothesize in this direction, which is what has been done, is that there's extra matter that can't be seen, which would account for the gravitational structure. But it's much better described by magnetism. So a spiral galaxy in particular is governed by a magnetic component, which does explain the rotational geometry. So that is explanatory, but it is hypothetical. But you'll see these pieces start to fit together as I go on, and I'll try to abbreviate this because we're already at 38 minutes. The final stage of the panther is what we now call the supermassive black hole. It's the final stage. It's the remnant of the explosion after the active galactic nucleus has appeared after the explosion. What's left over is a core called the core of a galaxy, the nucleus of a galaxy. It is called its nucleus. It's just the center, this more or less spherical center, which is at the center of our galaxy as well. And we've seen with super infrared telescopic vision to the center, which is very difficult to do because it's highly congested with dust and of course stars. But using infrared we can see all the way to the center, and this is where we've gotten the idea that we might be able to photograph a black hole. Now that has been claimed for M87, one of the nearest giant ellipticals to the Milky Way galaxy. It also of course has a supermassive black hole at the center. And I'm trying to tell you what that is. It's not what they say it is, but it kind of is. So here's a much better explanation for what is a supermassive black hole. Such has been claimed, has been photographed. That is not true. Obviously, you can't photograph something that has no light. So what has been discovered is the region of the gravitational locus. And that has a geometry that we can observe due to the motion of the stars around the center. And that's highly visible at our galactic center. They're going very rapidly around a gravitational locus, which is focused to a point. That is, the nature of gravity is that it has a center of gravity. Well, that center of gravity is so strong that the stars at the center of our galaxy, which have been mapped, and you can see time-lapse photography covering decades, showing the very rapid rotation of stars around this invisible locus of gravity. Well, actually, that's a Lagrangian point. And it's not an object. It's the geometric remains of a gravitational anti-collapse. And that's the panther, as it explodes, leaves a hole as it expands the space around it. This is where we get the idea of spatial expansion. It comes from a leaping panther at the galactic scale. As a galaxy is born, because it's an electromagnetic explosion, it produces a hole in space. And that is a supermassive black hole. It's literally a hole, but it's not an object. It might be, but that hasn't been proved. And I believe I can prove that it's not an object. That's very difficult to say at this point, but that's 40 minutes and that's enough. We'll have another lecture. I have to get something to eat. I am a little bit sick, so I may have to cough. Don't worry about it. I'll live. I'm under the protection of heaven right now. Of course, one does not want to tempt heaven, but I'm just telling you I'll be back. And if I'm not, you'll know what happened to me. So we'll be right back. This is Anagalactic. Stay tuned for the 7th Cosmic Unit, the most important lecture I've given in 2 years.